All right, worksheet 3 is talking about the relationship between velocity, speed, and acceleration. We haven't talked about speed, and that's really what the first couple questions talk about. Does absolute value have to, what kind of effect does that have on numbers? It makes all outcomes. I don't want to say positive because 0 wouldn't be positive, but it makes them all outcomes non-negative. And then for the second one, it asks, what effect does taking the absolute value of a function have on its graph? Well, if it makes the outcomes non-negatives, it reflects any y values that are negative, reflects them over the x-axis. To make them positive. So any part of your graph that goes below the x-axis will reflect it above and make it positive. All right, so these three situations that they give you then in the next couple examples, 3 or 4 situations, they go through and kind of walk you through how speed, how velocity, how acceleration are all related there. So the first one, they give you a velocity graph that's positive and it's increasing. And they want us to find the speed. So the first thing that we need to do is figure out what the situation between those two things are. So in the first situation, the velocity is, in this case, velocity is above the x-axis, so it's positive. And the curve is concave up, so it's increasing. You can also look at these y values here, and they show you that the values are increasing as time increases. Because the velocity is increasing, what do we know about the acceleration? The acceleration, if the speed's increasing, the acceleration is going to be a positive value. Remember, acceleration is talking about the slope of the tangent lines. If you look at slopes for any of these tangent lines, those will also be positive values there. So the acceleration is positive. Let's fill in the last column for this chart as well. So it asks about speed. Speed's just the absolute value of the velocity. Well, all of our velocity values are already positive, so they're just going to stay the same. So the speed and the velocity for this particular example are the same because they're already positive. So it says by examining the graph, the by examining the graph of speed and the table of values, we can conclude that the speed is, and in this case, it's increasing. If you look at those values are increasing. All right, so the graph was concave up, the curve was increasing, the curve was above the x-axis there. All right, if you look at the next situation then, so now this one we have a velocity graph. We can find the speed. It's just, remember, the absolute value of the velocity. So it would be 1, 2, 4, 8, and 16. All of those values as non-negatives. In this case, the velocity, if you look at your values for velocity, they're all negative. You look at the graph. If this is the velocity graph, the graph is below the x-axis, so those values are negative. The curve itself is decreasing, or the values for your velocity are decreasing. And then the next one says because the velocity is, we just said, decreasing, we know the acceleration is, well, if you think about the slopes for these lines here, the slopes for these tangent lines, which would be our acceleration, are also negative. The last part that says we can conclude that the speed is, if you look at the speed, the values that we just came up with, those are increasing. Okay, same idea, third situation. We'll tie all this together at the end here. So for this one, now our graph is below the x-axis, but you can see that the curve is increasing from left to right. So let's find the values for the velocity first. It's the absolute values for all of those velocities would give us, speed. And it says the velocity is, if you look at those values for velocity, they're negative. And these values for your velocity are going from negative 16 to positive 1, so they are increasing. And because the velocity is increasing, we know that acceleration, which is the slope of the tangent lines, if you look at the slopes are positive. And it says by examining the graph of speed and the table of values, we can conclude that the speed, if you look at your values for your speed, they are decreasing. All right, and then the final situation, which is going to make all of this make perfect sense. You look at this last situation here, our velocity is positive because the graph is above the x-axis. And if you look at the graph itself from left to right is decreasing. We can fill in the values for speed. Absolute values for these are just those same values. So absolute value of velocity gives us the speed. Because the velocity is decreasing, that means its derivative would have to be negative. And it says examining the graph of this speed and the values in the table. What can we conclude about the speed? The speed is also decreasing. So now this conclusion kind of wraps all of this up in the relationship between speed, velocity, and acceleration. So if you look back at the situations that we had, when v and a, so when the velocity and the acceleration, so when they were both positive, the speed was increasing. But it also happened when both of them were negative. So v and a have the same sign. When they have the same sign, then your speed's going to be increasing. When they have opposite signs, they're going to be decreasing. Oh, I jumped ahead. All right, so when they have the same signs. All right, in which situations was the speed decreasing? That's when your v and your a, so this was, which are the last two situations, situation 3 and 4, when v and a are opposite signs. So go back, I think they wanted, this was situation. So this was situation number 3 and number 4. And the first one was situation 1 and 2. Sorry about that, they wanted the problem numbers where that happened. And then your conclusion. So speed, the relationship for speed, even if you don't have values for that, if you know that the velocity and acceleration have opposite signs, it's decreasing. If they have the same signs, it's increasing.